Hello, scholars, and welcome to Lesson 1.4, Segment Addition Postulate. So the segment addition postulate just states that if point B is between points A and C, then a line segment AB, I'm going to go ahead and see if I can highlight this. Can I? Yes. So that AB, which is this part, right? So the part plus the other part, BC, is going to just equal the entire thing. So this entire line segment from A to C, that's kind of like our whole. It's kind of like our part plus our part is equal to our whole. So let's go through the examples and you'll see what I mean. So example number 1 says if point R is on line segment QS and given QR is equal to 5 and RS is equal to 6, determine the length of QS. So first we're going to draw our picture. So our line segment QS, remember how we name our line segment with the endpoints? So our endpoints are Q and S, and point R is just anywhere on it. So I'm going to put R in the middle here. Then I'm going to label my picture. So QR is equal to 5. So that means between Q and R, the length is 5 units. So I'm going to put 5 right in between Q and R. And RS is equal to 6. So that means R and S, right, this line segment between R and S is 6 units. So I put 6 right there. After I've drawn my picture and I've labeled it, now I'm going to write my segment addition postulate. Oh, actually, let me go back really quick. Sorry. QS, we don't know what QS is. So I want to actually go ahead and draw that part in too. All right. So, and again, see how QS is the whole thing. That's why I drew that. QS is the whole line segment, and that's what we're trying to find. So I put a question mark. All right, segment addition postulate. So my part plus my part equals my whole. So QR plus RS is equal to QS. Now I'm going to fill this in with that information from my picture and my question. So QR is 5. I'm going to put 5 underneath QR. RS is 6. So I put 6 underneath there. And I don't know what QS is, so I'm going to use a variable. I'm just going to use X. And now I can solve from here, right? 5 plus 6 gives me 11. So my answer is 11. Or I could just kind of look at this. If I know that QR is 5, RS is 6, I know this whole thing is going to be 5 plus 6, right? It's 11. But we're going to go ahead and still write this segment addition postulate every time because that gets us used to doing it for the next kind of questions, which will be example number 3. All right, so example 2, that was pretty much like this one. We're going to go ahead and draw the picture. So point V is on line segment UW. That means my line segment is UW, and V is in the middle. All right, again, how do we know the endpoints? See how it's named UW? So I put U and W at the end. V is on it, so V is going to be in the middle there. And now VW is equal to 7. So VW, make sure you label this correct. VW is 7, so I'm going to put 7 in between V and W. And then UW is 13. So this whole thing is 13, right? UW, so the whole thing is 13. And I'm trying to find UV, so I'm going to put a question mark right here. So now I'm going to write my segment addition postulate. So the part plus the part equals the whole. UV is the part. VW is my other part. My whole is UW. And now I can fill in. I don't know what UV is. That's going to be X. VW is 7 and UW is 13. And now I can solve from here, which means I'm going to subtract 13 minus 7. And X is equal to 6. And doesn't that make sense, right? If the whole thing is 13, this part is 7. Doesn't that mean I'm just going to subtract 13 minus 7 to get this missing part right here, which is 6? All right, so now let's go to example number 3. Example number 3 is a little bit longer and more steps because now we're going to throw in some algebra. So the first part is just like the other ones where I'm going to first draw and label and write. So I wanted to get you guys used to that. So let's draw our picture. Point E is on line segment DF. So D and F are going to be my endpoints, and E is going to be in the middle. And it says DE is 2x, so I'm going to put 2x here. And EF is 2x minus 6, so I'm going to put that here. And DF is 3x plus 5, so I'm going to put that here. Make sure you label in the correct place because this is going to help us create our equation. All right, so now that I've drawn my picture, I've labeled it. Now I'm going to write my segment addition postulate, which is my part plus my part equals my whole. So DE plus EF is equal to DF. And I'm going to fill this in with the information from my picture and the question. So DE is 2x, EF is 2x minus 6, and DF is 3x plus 5. So I filled that in, and now I can solve my equation. But first, and this is why I reviewed algebra, right, the first 2 lessons, but we didn't review combined like terms. Let me just go over that really quickly. A like term is basically if they both have x or they're both a number. So on this side here, do I have like terms? Yes, I have 2x and 2x here. So I'm going to combine those first. So 2x plus 2x gives me 4x. And I write everything else down. You got to combine like terms, then you can solve. So then I'm going to draw my line, and I'm going to cancel out the variable. I'm going to choose 3x to cancel out. I'm going to do the opposite to both sides. That gives me x minus 6. These cancel out, and I got 5 over here. And now the opposite of minus 6 is plus 6. And I got x equals 11. Now I'm not done. There's one more step, because it's not asking you what x is equal to. It's asking you to find the length of EF. So I'm going to write down EF. And we got to look at what is EF. EF is 2x minus 6. So I'm going to write 2x minus 6. So my last step is to plug this value in so I can find what my length is. So I got to just, and again, this is from the first lesson, I'm going to substitute 11 for x. So I'm going to write 11 in parentheses. 2 times 11 minus 6. And now I just go ahead and multiply, then subtract. So 2 times 11 is 22, and 22 minus 6 is 16. So my final answer is 16. All right, so you're going to go ahead and do the practice now. You're also, actually, sorry, there is no mastery check anymore. So go ahead and just finish the practice. Let me know if you have any questions, if you're watching this during class or if you're watching this at home. Catch me next time, and good luck. I'll see you next class.